So here we have the questions, some of the advanced questions of the topic, potential difference between 2 points. Now the first circuit diagram that you see over here can also be represented like this. So it's just the same thing. I've rotated the image. The very same image has been rotated 90-degree clockwise. We need to answer for the potential drops at the point M and then point P and then point Q. How much potential would be dropped at those points needs to be answered. So let us start off with the potential drop across M. So you see, you need to find the PD, potential drop across M, or potential difference across M. And if I consider this thing as a single unit, you see this thing, if considered as a single unit, is connected parallel to the battery. And we know this for a fact. If the resistors are connected in parallel directly to the battery, then the potential difference across that unit equals to the EMF of the battery. So collectively, the potential difference across these two has to be 20 volts. Out of that 20 volts, 7 volts drop over here. So 7 volts out of the window. A potential of 7 volt has been dropped across the resistor L. And what are we left with? We are left with 20 minus 7, which would then be provided to the resistor M. So the potential drop across M would simply be 13. Or you can think about it this way. Only if you have 13 volts over here, only then the sum of this equals the EMF of the battery. So it has to be 13 volts. So I'm going to discard option A, option D also thrown out the window. So we have to choose between option B and C. Next, we need to find the potential drop across P. And it would be either 7 or 11. If we are able to find this one, then we can easily choose the answer instead of finding the potential drop across Q. We don't even need that. So the potential drop across P, that needs to be found out. So this one does not get easier than that. What we have to choose from 7 or 11. Like I told you, other options are out of the window. Let's say the potential difference across P is 7. Then the potential drop across these points would have been 0, because then you had to write 13 over here. If you subtract these 2 points, the potential difference across this resistor would have been 0, because 13, call it A, call it B. Then what is potential at A minus potential at B? It would have been 13 minus 13, which is 0, but that is not the case. It has to be 4 volts. And I say the potential across P is 11. Then thereby, to the sum of these two has to be 20 once again. So the potential over here would be 9. And over here we found already it was 13 volts. Now if you see the difference of these two, only then you'll be getting a 4 volts between these. If this is a point A, this is a point A, and this is a point B, the potential at point A would be 13. The potential at point B would be 9. Then the difference of these two has to be 4. So if I subtract these two, simply write the bigger voltage first and then the smaller one. Only then we get 4 volts as a potential drop between these two. So it has to be 11 volts at P, and obviously you see indirectly we also answer for the last one. Potential at Q or across Q has to be 9. So 11 and 9. So 11 and 9. So C is the answer for this one. Let's move on to the next one, which is a very easy one. The simplest way to answer this question is if you're provided with a bridge and that is connected with a voltmeter or ammeter, but no current is flowing through the ammeter, or there is no voltage being shown at the voltmeter, then what you have to do is simply cross multiply the resistors. So PS equals to QS. This is the shortest way you can answer this question. Or once again, the other method is the method of the ratios, which is, let's say this one, the ratio of this one to this one, P over R equals to Q over S. But then once again you get the same thing. And how do you get these two ratios equal? By the standard method. You find the potential at A, then you find the potential at B, and since there is no voltage, there is no potential difference between A and B, you put both of them expressions equal to each other, and from there you eliminate the extra stuff and then you reduce it to the values of resistance. And we need to find the resistance of the resistor R. So it could be 100 ohm, it could be 250 ohm, could be 300 ohm, could be 400 ohm, and this is what needs to be found out. What is the resistance of that resistor? That needs to be found out. If there is no current flowing through the ammeter, that would mean the potential at this point, let's call it point A, and the potential at this point would be same. So this one is positive terminal of the battery, this one is negative. The potential at this point for the battery on the left would be plus 12, and at the end it would be 0. Over here it would be 24, at the end would be 0, but we don't know what the potential would be here. But whatever the potential is here has to be equal to the potential over here. So VA should equal VB. Only then there can't be any current passing through the ammeter. If there were a potential difference, then there must be some current passing through the ammeter. So this is the most important thing. Ammeter reading is 0. Means the voltage at A would equal the voltage at B. We gotta find the voltage at A, and then we can find the voltage at B. So in order to find the voltage at A, I'm going to consider this circuit, this one, and I can use the method of cross multiplication. So I can write resistance here and I can write voltage here. So 12 volts would have been provided to the total resistance of 150. Okay, so collectively these two would have been provided with 150 volts. 12 volts. Okay, you can just break it down into something like this. The circuit on the left side. Okay, something like this. So this one is 12 volts, this one is 50 ohm, and this one is 100 ohm. And you need to find the voltage across this point. So the voltage across that point, let's call it point A. The voltage across that point, or the potential at the point A, would that equal, let me write it over here, potential at A. You have to pick from these two options. Potential at A, would that equal to the potential difference across 50 ohm? or potential difference across 100 ohm. What do you say to this one? The potential at A, does that equal to the potential difference at 50 across 50 ohm, or the potential difference across 100 ohm? What is that equal to? It would be the potential difference across 100 ohm, because whatever the voltage is out of 12 volts, some of the voltage would have been dropped across the 50 ohm, and the rest of it would go at the point A, which would eventually be provided or would be across the 100 ohm resistor. So what we have to do is find the potential at or across 100 ohm resistor, that equals to X. Then we can just cross multiply, and X would equal, so the potential at A equals 8, VA equals 8. And alternatively, you can say the potential difference or the potential across 50 ohm resistor would have been 4. You can just subtract it from 12. So 4 volts would drop across 50 ohm, and 8 volts would drop across 100 ohm. And that makes sense also, because this one has double the resistance, so double the share of the voltage would be across 100 ohm. Now what do we get from here? We get this thing, that the potential at B should also be 8 volts. This is what we need. The potential at B should also be 8 volts. So the potential across 200 ohm should also be 8 volts. And then we can say that indirectly, if the potential out of 24 volts, just take a look at the second circuit now. Out of 24 volts, 200 volts would be dropped, 8 volts would be dropped across 200. How many volts would be dropped across this one? Across R. How many volts would be dropped? The answer is very simple. It is 24 minus 8. Okay, just consider this circuit. So you were having a total of, let's say, 24 rupees. 24 rupees. And out of that 24 rupees, 8 rupees goes to one of your brother, and the remaining share has to go to the other one. And the remaining would be 16. So what we write here is there would be a voltage of 16 volts across the resistance R. Would be a voltage of 16 volts across R. Just try to recall the concepts of the circuits, especially how does the voltage across the resistance, or how is the voltage across a resistance affected by the resistance of the resistor, especially when these are connected in series. It's pretty much in front of us. Just matter of finding the answer. And even without doing the ratios, we should be able to pick up the right answer. The more the resistance, the more the potential. How do we know? V equals IR. The more the resistance, the more the voltage across it, because current remains same in the series circuit. Okay, so 24 volts over here, and we know this one has to be 8 volts over here, and we have 16 volts over here. This one is 200 ohms, and the other one needs to be found out. This one resistance needs to be found out. So for the total resistance, the total would be 200 plus R. For the total resistance, you're getting 24 volts. And if you need to find the potential across this one, then you can simply cross multiply. The voltage at R ohm, the voltage is given 16. This resistance is getting 16 volts. But how much is that resistance? We don't know. This is what we needed to find. 16 2s are 3200 plus 16R equals to 24R. Now I can hit it on the calculator. 3200 divided by 24R minus 16R would be 8R. So 400. But once again, we should not be using the ratios for this one, at least for this one, because if we see the double the voltage means there has to be double the resistance. That's it. That's the rule of thumb. Half the voltage, there has to be half the resistance compared to the other resistor that is connected in series. A circuit contains two batteries, each of negligible internal resistance, and two resistors as shown. So kind of an easy one, I think. The galvanometer has a current reading of 0. If you're provided with this thing, that means the potential at this point, let's call it A, would equal to the potential at this point. So in other words, the potential at A should equal the EMF of the battery X. Because what is the potential at B? That would equal to the EMF of the battery. Let's say if the battery is 12 volts, for example, if the battery is 12 volts, then you'll be getting plus 12 over here, 12 volts over here, and 0 over here. So you'll be able to say that potential at B equals the EMF of the battery. But the problem is we don't know the potential at B. But what we know is there is no current passing through the galvanometer, which means the voltage at B would equal the voltage at A. And the fact of the matter is voltage at A can be found very easily. So Manur beta, can you help me out to find the voltage at A? And I'm going to use the method of cross multiplication, so you can just tell me what should I write here.
So first we write the combined resistor, that is 12 ohm.
12 ohm and against
24.
24. And then
At 3 ohm.
Excellent. So VA has to be the voltage at across 3 ohm. The VA would equal to potential difference across 3 ohm. And keep it in mind, if they reverse the battery, if they reverse the polarity of the battery, for example, the battery is given like this now. In that case, it would be reversed because you have to follow from the positive side. So across 3 ohms, it would be X, and we can just cross multiply. Does not get easier than that. So 12x equals to 6 volts. Okay, so across this one you'll be having 6 volts, and the leftover would be provided to 9 ohm. It would be across 9 ohm, which is the leftover. 24 minus 6 would be 18. And see, it is once again consistent with our understanding of the ratios. This resistance is 3 times greater than the lower one. Hence, the potential across this one is 3 times greater than one at the bottom. Okay, but that was just a side note. It has nothing to do with the question. What we have to do is the voltage at point A, we have found the potential at point A equals 6 volts. So V at A is equals 6. That would equal to EMF of the battery X. So the EMF of the battery X has to be 6 volts once again.